For the second problem, it says Cavendish experimented with gravitational force in order to determine the universal gravity constant. So this value right here. All right, now pause right there. There's not really much you know about the gravitational constant. However, if you go to your equation sheet, gravitational constant, capital G, is going to be this big equation for gravity. It's actually this one right here. Sorry, I circled it and I was off the screen. All right, so the force of gravity equals G times mass 1 times mass 2 divided by the radius squared. That has capital G in there. This one down here, the bottom, also has G in it, but I'll show you why it's going to be the top one. All right, so back to the question. In his experiment, he started with two masses that are small in distance from each other and measured the gravitational force between them using the same masses. So he held the masses constant. All right, so back to our questions, the constants, right? He said he held the same masses every time. So mass 1 and mass 2 are both going to be the same. Not the same as each other, but the same in every experiment that he does. He changed the distances. All right, so that makes that a variable. The distances, now if you look at your equation, distance is actually measured in r. Now the reason for that, we'll talk about that when we talk about gravity, but the distance r is one of our variables. All right, so keep going. Same masses, change the distances, and measured the forces. So he changed the distances. That makes that the independent variable. And then to see what happens to the forces, that makes that the dependent variable. All right, so the forces, the force of gravity that's being applied, that is the other thing that's changing. That's a variable. So gravitational constant. So we use the force of gravity equation, all right? And the reason it's going to be that force of gravity equation and not the bottom one is because we're looking at the force of gravity. So force of gravity is going to be equal to G times mass 1 times mass 2 divided by the distance or radius squared. Okay, so part A, on part B, A, it says Cavendish linearized the data to determine the universal gravity constant. What would the y-axis be? Well, we already said the y-axis was going to be the independent variable, right? And again, we're trying to get our equation, when we linearize it, to look like y equals mx plus b. All right, so the y-axis, that's going to be our force of gravity. So force of gravity is the y-axis. The x-axis right here, is going to be the other thing we're changing, radius. Now notice radius is in the denominator and it's squared. So the linearized x-axis will be 1 over, put radius in the denominator, and then square it. So for every distance that you have, you square it and then take 1 over that, and then that's going to be your x-axis. That'll linearize your data. Now what is C? Well, C is everything left over in the equation, right? So we got the force of gravity, that's the y. We have the x is 1 over radius squared. The slope is going to be everything that's constant in here, okay? Everything that's constant. And I forgot to mention that up here, that G is constant, and mass 1, mass 2, those are all constant. All right, so what's going to be the slope? Well, the slope will be equal to, now that m means slope, not mass. Slope is going to be G times mass 1 times mass 2. So maybe it'd be better to just actually write slope equals G times mass 1 times mass 2. And then to find G, we divide by both masses when we find the slope of that linearized graph, and then that'll give it